Okay, absolute value function. First of all, you're going to need your calculators, to get to the absolute value. We're going to be graphing these. So you're going to hit your y equals. Then you're going to hit your math key, the math key button. So hit the math button. Then go to numeral or numbers. And then number 1 is your absolute value. Just hit enter. And put the variable x in there. Close parenthesis. Hit graph. And there, x is right here. You don't get parabolas. That's a quadratic. Okay, the directions are right here. Hit the math key, arrow over to num, and then the first one is your absolute value symbol. I can't see it. You're using your y equals. You're graphing this. Yeah. Okay. Here, let's do it again. Hit your y equals button. Okay. Now, hit your math key, arrow over to NUM, which means numbers, numerical. And then ABS, you could either hit 1 key or enter. Now put in X, close parenthesis, and graph it. It looks like a V. Yeah, okay, so I want you guys to do accurate graphs. First of all, this is not a mother graph, okay? It's called the parent graph. Yeah, it's the parent graph. Now, I want to get some really accurate points here. So, I'm going to go back to my calculator, hit the second key, hit graph key, and it brings up a table. Sometimes your calculator, people are going to mess up. Okay, you should, on your table, you should get points 0, 0, 1, 1, 2, 2. Okay, so 0, 0, 1, 1, 2, 2, 3, 3. Get yourself a nice straight edge. So here's one side of my V. Now, you're probably saying to yourself, well, wow, this kind of looks like a line that should continue on. What do we know about absolute values, though? They can never be negative, right? So there's no way that my y value can ever be negative. So that's why it does a turning point here. When I plug in -1 for x, I get +1. When I plug in -2 for x, I get +2. That's why we get this turning point. We get a V. Make sense? I know you guys sleep on that one tonight. So there's a graph. There's the parent graph of the absolute value of x. Yes. No. I don't use a calculator for many of the functions that we're going to learn. Okay, now, back when you learned parabolas in Algebra 1, yes. Back when you were learning parabolas in Algebra 1, we had quadratics where y equaled x minus h squared plus y minus k squared or something like that. Oh, that was a circle. But we shifted the parabolas, right? We shifted the parabolas. Now, here's the equation for absolute values. I have a times x minus h. I'm sorry, absolute value plus k. You have to guess at it. What do you mean? You could see this just fine. Oh, I had it like this. All right. So, this is absolute value symbols. So my h here, h is going to tell me left or right. K is going to tell me up or down. A is going to tell me the slope, and the sign in front of A, we're either going to have a positive or a negative. The sign in front of A is going to tell me reflect or normal. Okay? The negative obviously is going to reflect. What's that? No, this is normal. This is the parent graph of absolute value. Everything is normal. Everything that we do, and we'll probably do this all year long, describing the transformations are going to be compared to the parent graph. So when we look at the radical exponential function next week and logarithmic functions and circles, it's all going to be compared, the transformations are going to be compared to the parent graph. You have to tell me those transformations. Which way? Which way? This is a circle. Don't worry about this. We're going to do circles 2 weeks. All right. Ready? Okay. Tell me. I'd rather not. You know what? Shh. Once you learn these transformations, it's so much easier to do it without a calculator, because calculator to me takes time. Punch it in. Well, let's figure out the shifts first, then we'll punch them in, okay? When I have my h is what here? It's 2, positive 2, because my sign is negative already. In my formula, the sign is negative. So which way am I going to go? It's positive 2, isn't it? Yeah, it is. It's positive 2. Remember, my formula doesn't change. Okay, I have y equals a absolute value of x minus, and then plus k. These never change. That minus sign never changes. This plus sign never changes. Okay? So, I've already got my a is 1, so it's not showing up. My x is there, my minus sign is there, so what do I have? A positive 2 that I would put in there. In other words, you're going to go the opposite way of the sign inside the absolute values. Okay? Yes. Okay, since this is a minus sign in here, I'm going to go right to the opposite side. Okay? So, you can either plug this in your calculator, or you could just take our vertex. This is the vertex, 0, 0. By the way, the vertex is HK, and in our parent function, it's 0, 0. Okay? Okay, so I'm going to go right to, so my vertex is going to go right to, everything else is the same, so I could actually do this in my head. 1, 1, 2, 2, and then do the slope the other way. 1 over 1. To me, it's easier than taking your calculator, go to your y equals, clear it out, go to math, number, absolute value, x minus 2, close, and graph. You could do it in your calculator. It's not negative. It's not reflective. We'll get to a reflective. Hang on. Number 5 is reflective. What do you mean? Not very high. This would be good enough. Okay, number 2. Now, my 3 here is inside the absolute value, so it's an H. Okay, it's an H. Which way am I going to go? Left 3. So I'm going to go left 3. That's my shift or transformation. If you want to do it in your calculator, no problem. Just go to your y equals. This time I want a plus 3, hit graph, and I can go to my table and get some points. Let's see, I've got negative 3, 0 is my vertex. Do you see my vertex on your calculator? Huh? X plus 3. Does everybody see my vertex on the calculator? If you want to know how to use a calculator, the way to find your vertex, see the y values? They're starting to repeat, aren't they? The y values are starting to repeat. So this has to be my vertex, negative 3, 0. Huh? Should you use absolute value? You have to put in absolute value. What little calculator trick? Huh? Oh, hit second graph. That's your XY t-chart. Okay, so my vertex is at negative 3, 0. And then I've got negative 4, 1. Negative 5, 2. Or you could use your slope of 1 over 1.
Is it always 1 over 1?
My A here is 1.
Oh,
so my slope is 1 over 1.
Oh.
Depends on what my A is.
6 would be 3 over 1.
Yes. So number 6, my slope would be 3 over 1. How about number 3? Yes, because my A is 1 here. What do you mean slow down? Well, you could scroll up and down. Use your up and down arrows. Okay, huh? That's fine. Okay, you want to find your vertex. Okay, the way you find your vertex on your calculator, there's a couple of ways, but the easiest way is, hey, look for your y values that start to repeat. Okay, in this case, here's positive 1, here's positive 1, here's positive 2, here's positive 2. So my vertex has to be negative 3, 0. Look at negative, for your x value, look at negative 2. And then look at negative 4. What are your y values? Guys, quiet down. Number 3. Now, this 2 is outside my absolute values. So that's my k. It's going to tell me up or down. Now, in my formula, it's already a plus sign. And here my k has a plus sign. So what am I going to do with my whole graph? Up 2. So this is going to go up 2. Then it would go down 2. Yes. Yeah. This sign you follow. Yes. So this one you're going to follow the sign. And this one you're going to go opposite way. Okay, a lot of students think of it that way. Okay, so number 3, I'm going to go up 2. Now, if you want to use your calculators, that's fine. But this is easy because this is only one transformation here. When we get into problems with 3, 4 transformations, then you're going to want to use your calculator. But remember, we're comparing this to our parent function. All I have to do is move every point up 2. So my parent function starts at 0, 0. Well, I'll just go up 2. And then my slope is 1. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Sometimes it's easier to do this without a calculator. Okay? How about number 4? Down 4. So, yep, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Yeah, my slope is still 1. Up 1 over 1, up 1 over 1. Okay. Number 5. Now, the sign is going to tell me to what? Now I have a minus sign. Now I'm going to have to reflect over the x-axis. Okay? I have no other transformations. in other words, my A is 1, but I've got a minus sign there that's telling me to reflect. So my slope is -1/1. You can think of it that way. So my parent function's vertex is at 0, 0. This time I'm going to go down 1 to the right 1, down 1 to the right 1, down 1 to the left 1. And there's my reflect over the x-axis. Yeah, this is going to be a part on the quiz. And let's do one more. This whole number here, greater than 1. Now my slope is 3. It's actually going to tell me to vertically stretch this. So vertical stretch. This one I may want to do on a calculator, because these are kind of hard. So I got to go to y equals. I'm going to put in 3 times the absolute value. So I hit my math and then pick up my absolute value. So I have 3 absolute value of x. Close the parenthesis. Hit graph. See how it stretched it? X. I put in 3 times the absolute value of x. 3 times the absolute value of x. Now I'm going to go to my table, pick up some good points. Oops. Let's see if we can't find the vertex in here. There's my vertex, 0, 0. And then I've got 1, 3, 2, 6, -1, 3, -2, 6. Yeah, slope is 3/1. So if I start here, it's 1, 2, 3, 1, 1, 2, 3, 1. I know, but some people don't like it. Hey, guess what? Yeah, let's not do any homework today.